In this video we have some questions to answer regarding this rational function here. As usual, you can pause the video and see if you can go through these. We got the rational function f of x is equal to x plus 5 over x minus 1. And the first question is, what is the domain of the function f? So for a rational function, you want to make sure you don't include numbers in the domain that make the denominator 0. So all you really have to do for a rational function is look at the denominator. Is there a value for x that will make that denominator 0? Well, you can see that if I replace the x by 1, 1 minus 1 gives me 0. You can't divide by 0, so that has to be restricted from the domain. The domain is simply the permissible values of the variable. If you have a polynomial function, there's never going to be a restriction. The graph is continuous, no breaks in the graph. But with a rational function, you have to be concerned about values or numbers that make the denominator 0. So in this case, anything's permissible except 1. So we can say the domain of x, or the domain of the function I should say, is the same as all real numbers except 1. So this is one way we can write it in set builder notation. Domain again is all real numbers x such that x cannot be 1. Problem number 2 is the point 26 on the graph of f. So this is saying, is it true that when x is 2, y is 6? So let's evaluate the function at 2. Put a 2 where the x is. 2 and 5 is 7 in the numerator. In the denominator, 2 minus 1 is 1, so it gives me 7. So is the point 26 on the graph? Here the answer is no, because it's just saying when x is 2, y is 6. So it turns out actually that the point 27 is on the graph, but 26 is not. Go to the next one. If x is equal to 3, what is f of x? So this is simply saying, evaluate the function at 3. Put a 3 where the x is. 3 and 5 is 8. 3 minus 1 is 2. Got 8 divided by 2 is 4. So for this one here, if x is equal to 3, what is f of x? F of x is 4. And then what is the point? What point is on the graph of f? Well, this is simply saying x is equal to 3, y has to be 4. So that's the correspondence. F of x then is 4 when x is 3. For the second part, what point is on the graph of f? Well, it's the point 3, 3, 4. And then for number 4, the last one here, if f of x is equal to 9, what is x? So what value of x generates a value for the y value? F of x, remember, when you have a function y equals to f of x, we can write this as x and y. That's the coordinate. But remember, y and f of x are the same. That's the same thing as f of x. So if x is 9, what is x? You just take the function x plus 5. So we had f of x is equal to x plus 5 over x minus 1. And we're given f of x right here to be 9, so we have that. So basically to solve this equation for x, let's get rid of the fraction by multiplying through by x minus 1. So again, multiplying the left side by x minus 1, or multiplying, say, 9 and x minus 1, I get 9x minus 9. Multiplying these two here. And then for the right side, the x minus 1 and the x minus 1 cancel, so that gives me x plus 5. And then we subtract minus x here and minus x up here, isolating the x. That gives me 8x on the left side. This x over here cancels, and then we add 9 here to both sides. Minus 9 and 9 cancels. 5 and 9 is 14. Divide here by 8, both sides by 8. These cancel out. And I get x is equal to 14 over 8. I can reduce that by dividing by 2. So 14 divided by 2 is 7. 8 divided by 2 is 4. For this first part, what is x? If f of x is equal to 9, well, x is equal to 7 over 4. So that's the answer to the first question. And then what point is on the graph? X equal to 7/4. So 7 over 4, that's your x. Remember, the f of x, that's your y. So this is 9 here. So those are the answers to these. For the first part, x equal to 7 over 4. And the point that's on the graph of the function f is 7 over 4 and 9. Thanks for watching. We'll see you next time.